Okay, good afternoon, and welcome to Python 3 10 years later. This is Victor Stinner. Give him a welcome. Thank you.
So hi everybody, my name is Victor Stinner, and I'm going to talk about Python 3 10 years later. I'm a CPython core developer since 8 years now. I'm working on CPython and OpenStack for Red Hat. Working on Python means, for example, to review pull requests, to triage bugs, to help newcomers, to mentor people. It's mean a lot of different things, and I'm a very happy user of Fedora and Vim. I decided to organize my slides in 4 parts, the 4 seasons, and let's start with autumn. The birth of Python 3 was in 2006 with the PEP 3000, which has been called Python 3000. The thing is that at this time, more and more people started to complain about design issues of Python 2, which are called Python warts, because Python 2 was used by more and more people, and they started to complain, but also because Python 2 was modified during the development cycle of the Python 2 branch. To give you an example, in Python 2 you have 2 different types. You have the small integer and you have the big integer. And depending on the value, depending on the operation, you may get a small or large integer. And so if you would like to test the type of a variable, you have to test for both types, which can be surprising and disturbing for newcomers. And during the development of the Python 2 branch, we added a new kind of class, which is called the new class. You have to inherit explicitly from the object type, and if you don't do that, you get the old class. And the issue with that is that if you don't inherit from objects, you get the old class, and some Python features like properties are not working properly. Another example about Python 2 issue is that when you divide 2 integers, like for example when you divide 1 by 2, you get an integer 0 in the case of 1 by 2. And again, this is surprising for newcomers who are used to calculators, who expect a floating point number like 0.5. So it was decided to change that to return a float. And in Python 2, you already have an operator for that, which is a double slash instead of a single slash. For the Unicode, I would say like everything is fine if your application is only speaking Unicode. If you only take Unicode as input, your output is Unicode. If everything is Unicode, you're fine. If you're using only bytes everywhere, you're fine. But if you have some parts of your application which use bytes or other parts which use Unicode, you may get an exception when you pass non-ASCII characters. And that can be annoying because you don't get the error at compilation, and you don't get the error at the first run. It depends on the content, which can be surprising and can be an issue in production. For the comparison, in Python 2, we have something very strange, which is that you can compare anything. I mean that even if we don't implement the comparison operator between 2 different types, Python tries something for you to return a value anyway. For example, if you compare the number 1 and the string hello, Python will take the name of the type, like the string int and the string str, and compare these 2 strings to decide how to order values. And the result can be very surprising if you are not aware of this choice. So we wanted to change that to raise a type error in Python 3. And last but not least, the import in Python 2 are relative by default, which means that if you use the same module names and a name of a module in the standard library, you get a conflict and you can be very surprised by the results. So we decided to move to absolute imports by default. To limit the risk, we decided to don't break everything, only acknowledge warts. And we also decided to have an open community process for deciding what to change. In practice, it means writing PEP with a number starting with 3000s. And we didn't want to re-implement the interpreter from scratch, because if you restart to write a new interpreter from scratch, maybe you will get some subtle behavior differences, and we really wanted to limit the number of incompatible changes. And finally, to announce to everybody that they will have to do something, we planned the end of life for Python 2 from the beginning. And finally, in 2008, the Holy Grail, Python 3. We got it. At the beginning, we had a first migration plan, which was very, very obvious. Python 3 comes with an application called 2 to 3 to port your application from Python 2 to Python 3. And the migration is done at once. So you run the program, you're done. But maybe if we are still here discussing a Python 3 10 years later, maybe it wasn't the best idea. Because dropping Python 2 support was a no-go. It means that when you are the maintainer of a module, maybe you don't want to lose all your user base, because when Python 3 has been released, many Linux distributions, for example, didn't provide Python 3. So it means that if you lose Python 2 support, you lose your user. And I don't know what it means. Another issue about porting code is that if you have dependencies on your application and a single dependency in all dependencies is not compatible with Python 3, you are not able to run your application because you will get a syntax error or something else. So you really have to first work on dependencies, and if you have many of them, it can take a lot of time. And the final point is that we knew that Python 2 was used, but we didn't know that it was so heavily in production. So it means that when it's used in production, it takes a lot longer to move the code. Another issue about the migration to Python 3 is something called the technical debt. So imagine that you are a developer, you are discussing with your manager, and your manager asks, why should I let you work on Python 3 support? And the developer, oh, for all these new cool Python 3 features, obviously. Okay, but can we use these features? And the developer, well, since we still have support Python 2, nope. It means that it's very difficult to explain to a manager what is a debt, because you don't give any value immediately. It's something that you will get longer. Nobody knows when, because we are still discussing supporting Python 2. And when you would like to port your code to Python 3, you may want to use two different branches in your source control management, like Git. For example, one branch for Python 2, one branch for Python 3. Or maybe another choice is to really split the repository, to fork the repository. And some project has been forked to add the Python 3 support. For example, the DNS Python module has been forked as a new name, DNS Python 3. Sometimes the upstream, like PIL, doesn't care of Python 3 for different reasons. So the community decided to fork this project PIL under a new name, which is Pillow. So not only they ported the code to Python 3, but they also added new features. And in the worst case, the upstream simply doesn't reply. They don't read issues. They don't read pull requests. It's basically dead, but you still depend on this very important dependency. For example, I'm working on OpenStack. On OpenStack, we use the favorite database in MySQL. And to access MySQL, we used MySQL Python driver, but this one didn't support Python 3, sorry. So someone forked MySQL Python under a new name, which is MySQL client, to add Python 3 support. and to add new features and to fix bugs. But we got some issue because about the packaging of the module, it's a different name, so we don't know what is a new upstream. Because, for example, maybe the previous maintainer will wake up and continue the development. We got a lot of troubles because of that. To explain you other issues that we had is that when Python 3.0 has been released, the stable version of Python 2 was Python 2.6. And this version requires a lot of changes when you would like to write a single code base for Python 2 and Python 3. There is something very convenient, which is a 6 module. It's a module which behaves the same on Python 2 and Python 3, but the implementation is different depending on the Python version. And when you use Python 2.6, you have to annotate a lot of code using 6. And if you really want to use new Python 3 features on Python 2, you have to use something called backports. And in Python 2.6, you need a lot of them because we added some Python 3 features on 2.7, but 3.6 was still the stable version. And about the specific case of the Unicode string, which is a string with a U prefix, you had to annotate it with a function called 6.u because if you use the U prefix, you get a syntax error until Python 3.2. So after the autumn comes it's cold winter. And we will start with the Python 3 wall of shame. This website has been created by someone who wanted not to blame maintainer, but it was an attempt to motivate package maintainer to post their code to Python 3. And when the website has been launched in 2011, we only had 9% of the top 200 projects compatible with Python 3. And I identify 3 big players in the Python community, which are Twisted, Mercurial, and Django. Twisted is a framework for networking clients, but also networking servers to write asynchronous code. Mercurial is a source control management similar to Git. And Django is a very famous framework for web application. It's an ORM templating engine and everything that you need to build your web application. So depending on the project, we had different issues. For Twisted and Mercurial, they work at the low level. For example, Twisted, you are working on the network, so on sockets, and at the socket level, you don't get Unicode. What you get is only bytes. So for this reason, Twisted is have a heavy usage of bytes. And for the case of Mercurial decided to use bytes for the file content, but also for the file name. And for this reason, it's much more difficult to move this application to Python 3, because in Python 3, the Unicode is a first citizen class type, and using bytes, it's more complicated. And about Django, they had a partial support of Unicode, but it was still incomplete at this time. Because of all this issue that I just described, we started to see something on the internet, on forums, on mailing lists, which are called, not the French, but the Python 3 trolls. Because of all these issues, the trolls consider that Python 3 doesn't bring anything, because as I explained with the dialogue between the maintainer and the developer, even if you move your code to Python 3, you still have to support Python 2, and at the end, you cannot use new features. And Python 3, according to the trolls, introduced new Unicode issues, because if you consider a Python 2 application which only uses bytes for everything, you never care about the encoding. You can get one encoding, and you can get a different encoding. If you merge the two texts, maybe some user will complain, but at the end, it's okay. No, it's not a big deal. So according to them, using bytes is just simpler. And after these discussions, I came up to a new idea. Okay, so maybe there are still a lot of Python 2 users. Maybe we can just continue the development of Python 2 because we can add new features, we can fork the project. And in 2014, there was an article on Linux Weekly News saying that we are still debating a transitional Python 2.8. So the concern was that Python 3 would never take off because according to them, the Python 3 only represents 2% of packages. And to calm down the trolls, what we did is to make it very, very explicit that Python 2.8 is not going to happen. So in 2011, we wrote a PEP called the Python 2.8 unreleased schedule. It's a PEP number 4004, the PEP not found. And in fact, it's not 2% of projects which were compatible with Python 3. It was closer to 80% if you only look at the top 50 projects on PyPI. And in my opinion, the best thing that we did in the whole Python 3 mess was that the last item is that in 2014, Guido van Rossum at PyCon US announced that we will extend the support of Python 2.7 from 5 years to 10 years. This is very a strong signal to Python 2 users because we didn't want to blame anyone. We didn't want to force people to move immediately to Python 3. We know that when you are working for a huge company with a giant pile of code, you need more time to port code. You have a lot of practical issues. So the message was that we still support Python 2. We are still fixing bugs. We are still fixing security issues. And we will do that until 2020. Okay, after the cold winter, we get the fresh air of the sprints with flowers. And the first very good news is that we fixed our first issue. And what is the first issue is that when you wanted to install something in Python, the question was how to install a dependency, and the answer was install setup tools. But how should I install setup tools? And you had to go to a specific website to download a script. You have to stress the website, and it was difficult to find setup tools. Later, we got a fork of setup tools, which was called distribute. So we got a lot of issues. But in 2011, PIP 1.0 has been released. And 3 years later, we included a module in Python 2.7.9 and Python 3.4, which is not really PIP itself. It's an installer to install PIP. And thanks to this, slowly PIP became the de facto installer for Python. So the newcomer didn't have to ask how to install something. The answer was obvious. It's now PIP. And moreover, the Linux distribution started to ship directly PIP, so you don't have to care about how to get PIP. It's already in your system. To port your code to Python 3, we saw that the first approach didn't work. So we came to a new approach, which is to stop promoting 2.3, which removes the Python 2 support. The new approach is very simple, is to add Python 3 support. And when I say that today, maybe it's obvious for everybody that it's a wise way to do that, but you have to understand that it took us a long time to understand that we have a huge user base. There are real good reason to not move immediately to Python 3. So it took us a lot of time to write new tooling, to write new tutorial books to explain that. And for example, there is a 6 module which has been created, but also new tools like Modernize on Sixer, which are tools to port your Python 2 codebase to Python 3. And the story behind Sixer is, this is my own tool, is that I wanted to port OpenStack to Python 3, but to port 3 million lines of code at once, you get different issues, because in OpenStack, the code was moving very quickly, and if you use something like Modernize to port your a single project to Python 3, you get a giant patch, and quickly the patch will be in conflict. So you have to rebase or regenerate the patch. So it's a nightmare to get a review on such patch. It shows a different approach. The idea is that you apply a single change, for example, just add parentheses to the print statements, and by doing that, you get a much slower, much shorter patch. It's easier to review because it's only apply a single kind of change. And thanks to that, I was able to port OpenStack to Python 3. And the other advantage of this role approach of adding support and not removing support is that you can do it one file after the other, or you can apply one specific change and after the other. And each change can be tested by the CI. So you can do it in multiple months. It's fine. If you have a very large code base, maybe you have some different issues. For legacy code base, one solution is first to write new tests, because you may know that in companies, people like to put new features, but not to spend time on tests. Or maybe the culture of the company is not to write new tests. And thanks to tests, you are able to reduce the number of regressions. And another approach tested by Dropbox is to annotate the type of the function parameters using a tool called MyPy. It's a static analyzer for the types. And they are also working on the typing, which is a standard way to describe the types for annotations. And thanks to that, they plan to port something like 5 million lines of code to Python 3. In addition to all the previous parts, is that we are also building bridges between Python 2 and Python 3 to make the transition simpler. For example, Python 3.3 reintroduced the U prefix for Unicode strings, which avoids to annotate each string using the 6.u function, which was a no-go for many maintainers. Python 3.7 adds the bytes formatter, which is very important for projects like Twisted or Mercurial. But in Python 2, we also added new warnings, new Python 3 warnings. And the cool thing with that is that even if you don't start to port your code to Python 3, you can already take a look at all these warnings, and you can already start to fix these warnings before starting the real migration. And in parallel, we got more and more backports, which allows you to use new Python 3 features in Python 3. So in consequence, you can use Python 3 in practice. And after the spring comes the summertime. So to come back to my previous slide about the wall of shame, the author of the website changed the title of the page from the wall of shame to wall of superpower. And the good thing is that we are almost at 100% of the top 200 projects compatible with Python 3. It's not exactly 100% because in this list you have a lot of, you have 10 projects which has been deprecated or replaced by a different solution. So I think we are good for these modules. The other good news is that Python 3 is finally faster than Python 2. On this graphic, you can see that all results are normalized to Python 2. And if something is below the orange line, it means that Python 3 is faster. So on this graphic, I showed the benchmark where Python 3 is the most fastest. And there is just one case where Python 3 is still slower. It's startup time. But we are working on that issue. Oh, and something else, the other good news is that Python 3.7 is coming next month, in a few months, and it's already faster than 3.6. To give you another number of our performances, the Instagram company moved their application in production from Python 2 to Python 3, and they reduced the CPU usage by 12%, and the memory usage, they saved 30%. Okay, if you didn't follow the development on Python 3, this is a quick recap of Python 2 issues and what we got in Python 3. First, you have to know that since Python 2 is used for a long time, we know more and more bugs. The list of known bugs is growing. And for some reason, we cannot fix some issues because of the thing called backward compatibility. To give you a concrete example, the Unicode supports. Maybe we can do something in Python 2 to raise an exception if you merge a string of bytes and a string of Unicode, but we decided to not touch this part because it would break like all applications in the world. Another example is it's an attack on the dictionary type. When you generate very specific inputs, you can make Python much slower and so crash a server on production. We fixed the issue in Python 3, but in Python 2, even if we implemented the solution to prevent this issue, which is called the hash function randomization, we couldn't enable the fix by default because it would break the backward compatibility. And after that, you start to enter a very dark place, which are called the race condition. This kind of bugs are very, very annoying, very difficult to reproduce. It means that usually you saw it very frequently on production, but you cannot reproduce it on your development laptop. One example is a subprocess module, which is not thread safe, which means that if you spawn a subprocess in your application in 2 different threads, maybe you will get a crash. You have to be aware of that. Another example are the recursive lock. They are not signal safe, which means that if you spawn a subprocess, when the subprocess completes, you get a notification as a unique signal, and this signal may make the recursive lock inconsistent. One last example is that Python uses internally clocks for different operations like timeouts, and we are using the system clock, which cause some troubles if the system administrator changes the system clock. Your application may be stuck for 1 hour or may crash. We don't know. But the good news is that we already fixed all these issues. So just upgrade to Python 3 and you will be good. For example, in Python 3.3, we added a new monotonic function. It is used internally to implement timeouts. And the good thing with Python 3 is that since the user base is smaller and since it's seen as a newer project, we are allowed to do incompatible changes because Python 2 is seen as something like super stable and nobody wants to break it. But in Python 3, it's kind of okay if you are able to limit the risk. To give you a concrete example, in Python 3.4, we changed the file descriptor to make them non-inheritable by default, which means that if you use fork plus exec, by default, you will not inherit open file descriptor. This is very important in terms of security because if you open a file like your secret password on spawn or subprocess, In Python 2, if you use fork plus exec, you will inherit the sensitive file. You can also imagine the case of a very important network connection. Again, you inherit the open connection in the subprocess. It's not really what you expect when you spawn a new process. In Python 3.5, we change how we handle signals. It's a little bit more technical, is that if your application gets a unique signal, by default, the system call is interrupted and you get an error. In Python 2, the function calls get an error, so you had to loop yourself until there is no more exception. But in Python 3.5, what we did is that if the signal handler doesn't raise an exception, we retry the function call for you, so you don't have to do anything. So it makes your application safer and more reliable. To explain the idea of breaking backward compatibility, Guido van Rossum wrote, when he approved my PEP for non-heritable file descriptor, we are aware of the code breakage this is likely to cause, and doing it anyway for the good of mankind. And again, about Python 3, you have to know that we added a lot of new features. Just to give you an overview, we added not less than 21 new models. That's a lot. I will not read the full list, but to give you some examples, there is async.io, which is a great module to write asynchronous code using async and await keywords. There is the enum type. There is a pathlib, which is very popular to handle path. There is also the very useful unit test.mock. If you don't know this one, please try. It's really helpful to write unit tests and limit dependencies on the other part of your code. So not only we added new features to the standard library, but we also modified the language. We added new features. For example, in 3.6, we added something called the Fstring. And in my opinion, this is just the best way to format a string, because it's very short, it's very obvious when you read the code what it means, and it's also very powerful because you can write any Python expression that you want. For example, you can call a method, you can apply an operator, you can do whatever you want. Just don't not abuse this one, please. For the asynchronous programming, the first change was to add something called generator delegation, the yield from. So async.io started to use this one because it's a nice way to write asynchronous codes. But for async.io, it was still a little bit surprising for users because the meaning of these keywords is confusing. So we added two other keywords, which are async and await, and they became real keywords in Python 3.6. Because when you read the code, it's much more obvious that this function is asynchronous, and awaits really means that you are awaiting for something. More recently, we added support for asynchronous generators, which means that in an async function, you can use yield. This is very useful for to implement more advanced function in the asynchronous programming. And finally, we added asynchronous list comprehensions using async for or await inside the list comprehension. But we got more changes. For example, you get keywords only, which are very useful to prevent breaking application, because keywords only, you can add them, and you really have to pass the name of the parameter, otherwise you get an error at runtime. For an example of keywords only, you have the print function. Oh yes, this one was a statement in Python 2, and in Python 3 it became a function, the print function. For unpacking, we add the star to unpack the end of the list as a star tail. But now you can also use to build new lists. You can use star anywhere. And you can also use double star to unpack a dictionary, to create a new dict. And something which looks very simple, but in my opinion adds a lot for the readability, is that now you can put underscore in numbers to group digits to make it much more easier to read. For example, to write 1 million, it's much easier to read when you group digits by 3. We can also annotate variables and not only function parameters. So using colon int, you can specify that this variable is an integer. For the context manager with, you can now specify 2 different expressions or more. Previously, it was limited to 1. Again, we reintroduced the bytes formatting, which is useful for Twisted, Mercurial, or any project which we prefer to use bytes for data. And the last one is a new operator. In my opinion, it's very important for NumPy and scientific world, because previously you had to use NumPy dot function to multiply 2 matrices, and now you have a dedicated operator. It's much better. Okay, so we saw that projects are migrated to Python 3. Python 3 is much better. So is it time to bury Python 2? In fact, if you look at the Linux distribution, the move already started. For example, Fedora 23 and Ubuntu of the last year doesn't come with Python 2 in the base system, which means that if you install a new computer using this operating system, there is no Python 2. So it means that the migration is ongoing. But obviously, if you install a Python 2 only application like Mercurial, you will still pull the Python 2 dependency. Something else is the Python 3 statements. It's a global timeline of all projects, mostly in the scientific world, which show when the Python 3 support has been added, but also when Python 2 will be dropped. So using the timeline, you can get an overview of when you should move to Python 3 only. There is also the Python clock, which is a simple countdown until the end of the Python 2 support, which is the 1st of January 2020. And last year, we started to see major Python applications like IPython 6 and Django 2, which dropped Python 2 supports. So they are now Python 3 only. And in my opinion, for the case of Python 2, it's a very strong signal because Python 2 is a big project, is used by a lot of people. So if Django is able to move to Python 3, maybe you are also able to do that. Okay. So, Python 4. What's the plan? In practice, what we decided is that maybe we made some mistake in Python 3. I mean that we didn't prepare carefully the migration for Python 2 to Python 3. So what I would like for Python 4 is that it will just be the release after the previous Python 3 release, latest Python 3 stable version. So we just respect the same deprecation timelines that we are already using for the Python 2 branch. For example, first we deprecate a function in one release to announce that we are going to remove it, and only in the next version we remove the function. And sometimes we even use free release, like we first raise a pending warning, then a deprecation warning, to finally remove the function. So I think that we learned from our mistake, and we are not going to break the Python community one more time, because I think that we only got one bullet and we used it. So thank you, everybody. And if there is still time, maybe you can go for a question.
Yeah, so thank you to Victor. If anybody wants to come up, there's 2 sets of microphones. Just a reminder, questions are not statements, and they end in a question mark, and they're not a long story, so carry on.
I see Red Hat on your slides.
Yes.
When are they going to drop to?
So what we did in the Red Hat 7.5, which is the latest release, we announced that Python 2 is deprecated. And for the next major version of RHEL, we are going to ship only Python 3. So no Python 2. Yes?
Are there any features that you personally think would are on the horizon that would need a Python 4? Breaking changes that you can't just fold into Python 3?
When I discussed with Guido, maybe he doesn't share exactly the same opinion than me. He would justify breaking the backward compatibility again if we have a real change, like for example, Larry Hastings gilectomy, which breaks the C API. But today it's very difficult to know if we are going to do that or not, because the gilectomy is still experimental. We don't know. Yes?
Yeah, I guess in terms of like the kind of like the lessons learned from the transition from 2 to 3, was that sort of like the conclusion drawn from that, just that like if like some steps were taken better, it would have gone more quickly, or that this just kind of takes time, and that like kind of like the transition from 2 to 3 was kind of like it took as long as it had to take because of the nature of the beast?
Sorry, I didn't hear everything.
Oh, sorry.
Can you move closer to the mic?
Yeah, for sure.
Please?
I guess I was just wondering, in terms of why, or like kind of like the conclusions drawn from the transition from 2 to 3, was the conclusion just that like this is just kind of how long this sort of thing takes, or that if like some things were done better, it would have gone faster, and like this was kind of just like a learning experience?
Today it's very easy to say that we make mistake, but 10 years ago it was much more difficult to understand that something bad was occurring. So maybe if we do that again, we will be different. But I'm not sure that we could do it faster.
That looks like everybody. So thank you, Victor.
Thank you.